Hey everybody, this is Larry. This is me going with Q4 of the weekly contest 432. Maximize count of distinct primes after split. Hit the like button and the subscribe button, join me on Discord. Let me know what you think about this one. Yeah, so this one was actually kind of, I enjoyed this problem a lot. I dig this problem a lot. I think it's a very cute, interesting problem. And we'll go over it every step of the way, how I came up with the solution. So don't worry. And I know that the way that I explain it may be different from other people's because this is not. I want to focus on how I came to the solution, not which is not the same as the easiest way to understand the solution, right? Because it's good to understand the solution, but it doesn't matter if you cannot do it yourself. So that is the reason why sometimes my videos are a little bit explained in a different way, because I want to explain how I came to the solution so that maybe you can take inspiration. Doesn't mean that this is the only way to do it, but that's the best way I can, give you a unique perspective, right? But yeah, anyway, so I'm bringing up the drawing pad thing. Okay. For now, I'm going to skip the talking about the primes. It doesn't really matter, right? Like, primes is just a regular function that you have to measure whether a thing is true or not, right? So, like, for me, that's how I first thought about it. I'm like, primes is fine. We don't care about primes, right? So, like, for example, maybe you just have, like, the numbers do matter, right? But, actually, yeah. Maybe I'll take the first one. No, it's not in big enough a way, right? I'm just writing random things, right? Yeah, something like that, right? Like I said, whether it's primes or not, it's not that important. So the first thing that I thought was, honestly, somewhat part of it is I don't know if it's cheating, but it's just an intuition thing, right? I immediately thought, okay, this feels like a segment tree problem, but I have no way to confirm this, and honestly, that's not enough for me, right? It's just being like, okay, Larry, maybe it can be. So keep reading. Keep thinking about it. If it is, then you have it in your mind, right? And the reason is, I think it's just probably because we have to do like a lot of queries and it's big, and as a result, segment tree does a lot of these things, right? Okay, so and then the prime thing, we'll go over how to solve the prime thing, but as part of my thought process, prime is kind of, I wouldn't say trivial, but for me, I just knew that. Well, I know how to do the primes thing, and also all that matters is whether a number is prime or not, right? And then, so basically you use it as a black box almost, right? I mean, you have to be able to come up with the black box, but for me, I knew the black box, so I could come up with it. It's fine, right? And then for this one, it took me a bit to kind of think through what all these queries and all these things mean. But queries meaning, we have a live query, and queries are cumulative, right? Meaning that one query changes the state of another query. So that also is why I felt a bit segment tree, because now things change and you have to make them permanent, right? And then so these are kind of ideas in my head at this point in the beginning, right? And then after a little bit, I go, well, queries and stuff like that is fine, but let's actually try to solve. Okay, what would I do if I didn't have queries? Obviously, you would just do a for loop, but let's say you cannot do a for loop, because if you do a for loop, you can't do a for loop for every number, for every query. So I knew that, right? But let's say we have something like this. How do we solve it, right? It took me a little bit to come up with it. I was playing with some ideas, and if you watch the live portion of this, you'll see me coming up with like just examples and ideas to play around with. I try to do it on the screen, so versus my notebook this time, so you kind of see it like I was just drawing things out, like, okay, well, we have 2 and a 2 and a 5 and a 5, or like 5 5, what does that mean? What is, and then I was like trying to play around with like, okay, where does that mean? Where do we place the split or whatever, right? So I was playing around with all these ideas, and then the first thing that I noticed is that at some point, anyway, I don't know when I noticed this, perhaps the first thing I noticed is that, well, the middle numbers don't matter, right? So here you only care about the first number and the last number, right? And then you have something like this. And honestly, by now, like we think about, or I had some kind of visualization like this in my head, and by now I have kind of an idea And here maybe, I don't know, 5 could be here. It doesn't really matter. Because then now I was just visually thinking, okay, well, that means that we just want to cut here, because then now it cuts the 2 and the 2. I guess to put it another way, I knew that for every unique number that's in the array, for every unique number that's one, as it can, there are only 2 possible contribution, right? It could give 1 to the final answer or 2 to the final answer, right? What does that mean? That means that for a number, for example here, okay, let me clear this part actually. What do I mean by possible contribution, right? So for example, if you have a number, and just like there's a lot of 2s, and we always said that we don't care about the middle ones because if you put this here, it gives you the same answer as putting it here. So the middle ones, you know, like there's no differentiation as long as you put it in the middle. So we don't care about the middle ones. So we don't care about the beginning and the end, right? So that's first. And then the other thing is that, yeah, then now what are the states, right? So you have a 2 and a 2. Then there are kind of 3 different distinct ways of putting your divider, right? You could put your divider here, here, or here, right? So if it's this one or this one, then of course the answer is just 1 because both numbers are on the same side. The first and the last number are on the same side, then you're just going to get 1. But the interesting thing is, of course, if you put 1 in the middle, then now this will give you 2, right? Because now you have 1, 2 on the left and 1, 2 on the right. I know that maybe this part is more obvious once you know the other ones, but I promise you that it means something more later on, right? So because now, what does that mean? Now, what this means is that every number can only be 1 or 2, right? But put another way, that means that if you have n numbers, that if you have n numbers, another way to think about it is that you have n, well, that means that we have n prime numbers. Sorry, it has to be prime for the problem, but you have n prime numbers, then the answer is going to be n plus things that are split, right? I say things in a very vague way, but I just mean, like, you know, you're able to split 2 numbers. So number of numbers that you're able to split apart, right? And then this is where I have another visualization where I kind of already did that visualization a little bit, hinted at it, right? Which is that, okay, maybe you have, oh, how did that happen? Maybe you have 5 here, 5 here, 3 here, 3 here, 2, 2, or something like that, right? So the way that I thought about it is that, okay, well, we just have line segments, right? And then now you have line segment. What does that mean? Well, you have line segments and you're trying to find the max of like a split that overlaps all the segment. And this is a very common problem. If you only have to do it once, then it's just a regular sweep line, right? And honestly, at this point, I forgot about 6-3, or a little bit, maybe not totally. But yeah, you just have to find the max this thing, right? And as a result, but from the sliding window solution, another way to think about these segments, and this is how I came up with it. You don't have to do it this way, of course, or think about it this way. From the sliding window solution, which I'm not talking in detail about it. Maybe I should a little bit. But the sliding window solution is that, okay, for every beginning of the segment, you have +1. At the end of a segment, you have -1, +1, +1, -1, -1, right? So then now as you sweep from left to right, then now you accumulate +1s, and then now here it'll be +3, right? Because we haven't touched any of the negative ones yet, and we collected all the ones, right? So that's the sliding window solution. And once you do that, then now you can kind of, in a visualized kind of way, have like, and the reason why, like, if you kind of back out why we do this is because instead of, another way of thinking about this, instead of this sweep, is that, let's say we have this 5, we can add a +1 to every cell in between, right? And then, for example, +5 from like index 0 to 8 or whatever, then now you have like 8 of these +1s. And then for the number 3, maybe I'll change the colors. For the number 3, we have +1 here. Let's say it's here to here, right? So then now your array will look like 1, 1, 2, 2, 1, 1, right? This is kind of like prefix summed or difference array, depending on how you want to think about it. But these are some ideas that may occur. But then, yeah. And then now, you have +1 here, +1 or -1 here, which means that you want to do a +1 here, 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 right? And then now this means that this gets updated to 3, 3, 2, 2, or something like that. And then the answer is just the max of this, right? Because now we know that at a certain point we have 3 line segments intersecting, or like, you know, they overlap, right? 3 line segment at the peak overlaps at the same time, and that means that by how we defined it, that means that we split 3 numbers in the middle, and then now this is just n plus 3, for example, for whatever, like maybe we have other prime numbers that we don't cut, right? But yeah, okay. And then the segment tree, right? Well, the segment tree is the same idea. Now that we kind of backed it all up, and we have all these +1. Ooh, sorry, all these +1s, right? You have all these +1s. Then the segment tree is I want to say straightforward if you got this far and you're still following, because that means that we want to just add 1 to a range, right? We want to add 1 from here to here. And this one, we want to add 1 from here to here. Add 1 from here to here, right? That's it, right? We have 3. So now we have queries of add 1s. And that is basically it, right? Because then now you have a segment tree, you have a range query, or sorry, range update, and max over the entire thing, right? And that's it. That's all you need for this problem. There is something you know, you may ask, okay, we've done all that, but that works for one thing. We have to deal with queries, right? Well, queries is it's fine, right? Because then now it's just bookkeeping, right? And I'll show you one example of what I mean by bookkeeping, but I'm not going to go into too much detail until we go over the code. Is that okay? Let's say we maintain three segments like this, and then now you update a query, you change a number to another number, right? Actually, let me use it for this one, right? So 2 goes all the way from here to here, 5 goes all the way from here to here, and then 3 just, I don't know, kind of go here like this, but not actually, right? Actually, what this is actually no, because we don't want, because let me redraw this actually, because actually this is between the 2's here, right? Because we have to cut here, not including the 2, so this is more precise. And then the 5's we want to draw here because we want to cut like only what is cut in the middle of these chunks matter, right? And then the 3 we have no chunks because you can't have anywhere to cut, right? Okay. And then now, so what we do with updates? Well, I mean, you know, obviously if you update the middle, maybe it changes some stuff. But let's say like we change this 1 to 3, right? Well, 1 to 3, well, we look at the first 3 and the last 3, and then we're able to create a new segment here, right? And then of course you just do your segment tree query, get the max, you're done. Okay, so that's one example of what you can do with a query. Another one is, of course, if you manipulate an existing number, right? Well, I mean, then it just becomes breaking down. For example, here, let's say you want to get rid of this 2 and replace it with a 3 even, right? Then it honestly is just a decomposition of moves, because then now you just go back. Okay, we deleted the 2. This is the 2 line, right? The line segment that we have. We delete the 2. That means that we need to update this segment to here, right? So now your new updated segment is something like that, right? Using query tree magic. I mean, we'll go over the code, don't worry. But that's basically it. And then now the 3, we'll update the 3 to, well, 3 was here. So then now you update the 3 to here as a line segment with the query tree magic. And of course, you remove the old one first and then add a new one or something like that. I think that's the easiest way, because otherwise you have to do a lot more if statements. But in any case, right? And then now you're still able to just get the query in O of 1. Or sorry, with 1 query. I guess it's an O of 1 query. No, I mean, I don't know, because there's a lazy propagation. I guess probably should be okay now. But yeah, so that's basically the idea behind this problem and how I attacked it from part to part. I know that I still skipped the primes, but like I said, you can you can think about it as a black box, right? Whether a number is prime or not, and then just think about it that way. And we'll go over that in a second, right? So okay, so this is the segment tree code. Honestly, I think nowadays, I mean, I have it saved, but I think honestly, I've gotten this off ChatGPT, the segment tree template, at some point in the past, maybe. I have a few variations and similar. I think I just updated to write this, but because and the reason why we did this is yeah. I think this I don't know. Maybe this messes up actually because of the lazy propagation, but I think we're fine with the push. But in any case, because I think we push on the first one. But yeah, this is my segment tree code. It's just segment tree code. It is what it is. I'm not going to go over this video because otherwise it'll just be too long. But this is, like I said, a range update and technically range query, but I don't think I ever called this. So yeah, it's just something that I had and then get max, right? So you have lazy propagation. Where's the push here? And yeah, like I said, I'm not going to go over this. There are a lot of segment tree videos. Yeah. And then this is the prime. We just have prime sieve. You can also Google this. I'm not gonna go over this too much in detail, but yeah. The only thing that let me also go over the segment tree as well. It's just that the only thing you need to know is that update is log n, and get max is I guess technically all one, right? And you can see it. So yeah, that's the two things that you need to know for complex analysis. And prime sieve is going to be O of max log max, which for 10 to the 5th, it should be fast enough, especially since we put it outside the class, so it only gets executed once over all the inputs. And yeah, and now let's go over to it. We have segment tree. I always add a number of numbers. I don't know why. But yeah, but f is a terrible named function method, but it basically gives me f of x gives me the number of is the number is a list, a sorted list containing the index of x in the nums, right? So that's basically the idea is that okay, we have f of sub x, we track it in a sorted list because the reason why I like a sorted list is because we knew that that you have to add and remove. That's what I was looking for. I needed something to kind of keep track because okay, actually let me step back a second. So the reason why I had this is because I want to be, when I was thinking about doing this during implementation, was I need to know the first element and the last element in a very quick way, right? Given a number, return the first index and the last index very quickly. I knew that I need that, and I also knew that I had to add and remove indexes as they come up. And so sorted list was the best to go because things get removed. So like what used to be first might not be first anymore after removal, right? Makes sense, right? So basically I have a sorted list. We'll go over, I mean, as you know, I thought about this when I was coding, but of course you'll see how this plays out in a second. And then now for each number in nums, the initial input, we keep track of index and the x. Of course, we only care about primes. If it is a prime, then we add the index and f sub x. So far, so good. And then here, this is where we update the segment tree at the first place, right? We want to update the segment tree from first to last -1, right? And why would you may wonder? Okay, so first is the first index, last is the last index, right? Pretty okay so far. And these parameters don't matter. They matter for the seg tree. They're just seg tree parameters. Maybe I need a wrap around it. But I was worried about performance, and rightfully so because it's still timed out. But yeah. First to last -1, right? And the reason why there's a n-1 thing is that we call back to here. If we have a number, if we have two numbers right next to each other, then you only have one, because we're not adding on the segment. The segment is not on the index on the numbers, but the spaces in between the numbers, right? So you can think about like 3, and then there's a space 3 space another number space, I don't know, maybe another 3, right? Then now the segment that you want to join is between these two, not like inclusive of these 3, right? And as a result, and you could index this in any number of ways, right? But for example, if this is index 0, then this is also index 0. It's just like query. So this is 1, this is 1, right? So then now ... And you can see that if we're doing it here, even though this is index, say, x, this is going to be index x minus 1, right? So that's basically why we did it that way. I don't know why I said we, but, you know, me and you apparently. It's like I'm cheating, or maybe I don't know, maybe I have a split personality or something. I'm just like, that's why I'm good at these, because I'm working multiple personalities at the same time. But in any case, yeah, so that's why it goes from first to last minus 1, right? That's it. And here we want to add a +1 here. If you want to see an explicit plus, that's basically it. I even did a comment here. Did I just write this, or I don't remember. But yeah. And then now that's it, right? And if we call max at this point, we're able to get the max overlaps. Otherwise, then now for each query, we have an index and a value. But first, I mean, this looks pretty confusing maybe and complicated, but honestly, it's just breaking it down. It basically for each segment that I have. Okay. So first of all, we want to maybe another way of saying it, what is an update query, right? Update query is, so for example, update num sub index to wow. And what does that mean? That means, if you break it down, means we move num sub index, we move current num sub index, and then add num sub index to wow. Right? So that's basically how I first. Oh, sorry, excuse me. That's how I kind of break it down. And then once I have these two things, I break it down even more. For example, what does remove this mean, right? That means that we want to update the segment of the, maybe update, yeah, maybe remove previous. Maybe that's a little bit more precise. Update the segment of the previous num sub index. And what does updating mean, right? So update, we break that part to remove the old segment, create the new segment, right? And that's it. And then this is actually also the same thing. Update the segment of the previous, of the new now, right? Of the new num sub index. And what does that mean? That means remove the old segment, change, create a new segment. That's it. Maybe there's some optimizations that you can do to kind of like, make it like, if it doesn't change, then maybe it's okay. I don't know. Maybe I could have done that to save some time. I don't know though, because I feel like, I mean, is it enough for Leetcode? I don't know. There's no way for me to find out during the contest, right? I mean, the only way to find out is to submit. So it is what it is. But in any case, yeah, so that's this is the template of what we try to implement, and that's basically it. We're given the previous value. If it is a prime, we only keep track of primes. If it is a prime, we get the previous first and last. We update it by subtracting so we remove the old segment. We remove the old segment here. We move it from the indexing, and then also delete if because the reason why is because we use f.keys as the number of baseline unique primes, right? And then the split is just the max, and we'll show that in a second. But yeah, and then and that's really it. If there are no entries, we delete the key. Otherwise, create the updated old segment for the updated number, right? Because basically, if you remove the first or remove the last, then you're able to do it. Maybe I guess you can maybe like do some if statements to see if the index is first or last before you do these updates. But I feel like it just introduced more states and thinking and if statements, so that's why I didn't do it that way, even though it would be faster and maybe nicer. I don't know. Right, so anyway, so this is dealing with the previous prime, right? If it's a prime, previous value. And then now we go, okay, well, I guess this part is, I guess for consistency, we can just move it here. It doesn't really matter. And also it's too slow anyway, so it definitely doesn't matter now. But yeah, then after that, we update num sub index equal to val, right? We check that primes, if it is a prime and it has numbers, has more than one number, then we remove the old segment, and then we add it to the index. And then now that the indexing is up to date, we update it by adding one segment back in, right? And then at the end, the query's done. We have to get the answer. And yeah, the length of the f of keys is the number of unique primes, and then st, the max of the segment tree, give us the most overlaps, which means the place where we could split the most. And yeah, and that's it. So for each query, we do a lot of log n things. This is log n, this is log n, this is log n, roughly. This is log n, this is log n. I guess this is log 1 and this is log 1. But yeah, so a lot of log n things, but it's still log n. So it's going to be q times log n. Of course, setting up the segment tree initially is going to be O of n. And here is, I guess, technically O of n log n. So, oh, no. Well, yeah, because this is the number of distinct things. So the answer is going to be O of n log n plus q log n, right? Time. And space, we have linear space and q space for the answer. So yeah, that's it. That's all I have for this one. Let me know what you think. I'll show you the code one more time. Maybe I'll make it slightly smaller. I like to make it bigger for so people could see it, but now this is screenshotting things for you. This is the segment tree code, right? This is the prime zip code. This is most of the code, really. I mean, this is the pre-processing it into F and just declaring the segment tree. This is updating the segment tree from the first and the last entry. And then this is the entire query, mostly. Yeah. Okay, this is roughly right? I don't know. I had too many comments. Now let's remove some comments so that everything fits in one thing. So this is everything other than returning the answer. And yeah, that's all I have for this one. Let me know what you think. Thanks for watching, and yeah, you can watch me solve a live in the contest now. Okay, so like that is just stupid, right? I don't know. We have 15 minutes. Let's focus. That was a dumb problem, or dumb Leetcode problem, but it is what it is. Alright, Q4 maximum count distinct primes after split. I mean, you just have queries, index value, and then you have integer array, okay? For each query, update num sub index is equal to value, choose an integer k to split the array into 9 empty prefix and a suffix such that the sum of the count of the distinct, such that the sum of the count of the distinct prime values in each part is maximum. What does that mean? Alright. Okay. How do I even start this? It feels like segment tree, right? It's just like a random thing I have to know something about. And the numbers 5 to 10. I have one is surf there anyway. Write a prime. messed up. All right. Okay, so let's say we have the best answer. Right? How would you even think about it? I mean, the updates are fine. So then now you have so the thing is about distinctness. You want overlap-ish to be as much as possible, but how do you figure where to divide? Okay, let's say you do a pass, but there could be a lot of different cuts, right? How do you update in a good time? I ate so much candy. How much time do I have left? 46 minutes. Yeah, too much candy. Candy, garbage can of shame. Do you always divide? No. I was gonna say always divide around the same number, which is kind of true, but it's not sufficient. Is it? And here you can also even move 2 on the other side. Okay, let's say we keep track of all the individual numbers. If it's 1, it doesn't matter. If it's 2, then we want the median, right? So what does that mean? And then also, what if the thing is like, I don't know, 2255? Then we have to decide either here or here, so then we can't really separate them out. I guess we can, we just can't figure. I mean, but another thing would be, what if we have something like this? No, just like this, right? Then would you still want it here? Or would it be better if I do something like this or something? So okay, so what is the benefit of cutting it somewhere, right? Okay, actually, no, because it's distinct, so you only want the first and the last of each number. Okay, so that means that, okay, the first and the last of each number is here, then that means that and then there could be other things, right? Be like something like this, maybe even like this. How do you figure it out? Or even like this, maybe. Then how do you figure out you want? Okay, because you want to. Okay, so now we only keep track of the first and the last. And if we have something like this, what happens? It's like almost like intersecting line segments in a way. And the thing only updates. So the query updates only updates the first or the last or both, I suppose. Oh no, you have to be a little bit smarter just because you also remove stuff of a query, so that can actually change things. Let me look at the constraints real quick. Okay, n is big, query is big. Okay, so okay, let's say we have the things for all the first and the last. And the queries update, so you can't do them in any order in case that's a thing. So it has to be live-ish. So okay, so for every number, how many primes are there? Maybe that's a thing actually. 10 to the 5th primes under 10 to the 5th. 10,000. Still too much for me to brute force on each query, I think. That's an interesting idea. Is it though? No, yeah, I mean you can brute force, that's for sure. But okay, so each prime number contributes 1 to the answer, unless it gets split by a thing. You could do that with a is there a prefix sum idea? So basically, you're adding a prefix sum from do to do, and you're trying to get the max cut. And then the max cut will give you the number of prime numbers that are on the left and the right and dissected. I think that's right. So maybe sec tree is the way to go, right? Because then now we do 2 updates. I think that sounds right. Yeah, I think that's right, maybe. I don't know. We'll see if it is, honestly. I mean, the idea seems reasonably okay. But then now we have F. No, yeah. Something like that. And now I'm going to say for index x dot append index. Oh, yeah, I guess we add index in this case now. This is sorted list. Okay. And then now in the segment tree, right? So for key in f of keys, we want to say seg tree. No, okay. We want to get the first element and the last element. So f of k. So that's the first element and the last element. And they could be the same. I think that shouldn't matter. And now it's just seg tree. I forget my I have to write it. First plus 1. Wait, is there a thing? Oh yeah, no, that's fine. We just add it to a range, right? So we just use lazy propagation with seg tree. I feel like there is one with a different array, but maybe I'm wrong. Okay. And then that should be close to good. We have to write out the seg tree. Yeah, okay, let me try. Let me find my segment tree webhook. Range update get max. That's a pretty standard one. I should be able to just find the actual one. Okay. Yeah, okay. I always forget what this is. This is one indexed. Yep, okay. So then now I should have one with helper one. So it's first to last. I don't know if it should be inclusive or not. It seems right. Maybe they should not be when. Should be inclusive, so okay, fine. If there's only one, then this should be good. Okay, is that true? Maybe I should just skip it then, right? Because it adds one contribution when it shouldn't have. Okay, so let's say we have between 3 and 4. We actually I want to add 1 to 3, not 3 and 4 inclusive. So last plus minus 1 sounds good. Okay, those are the nodes, right? I think. I always forget which one is the parameter, which one is not. I need to have notes on my thing, but I think that's array elements, right? So 0 and minus 1. Is it n minus 1 or n? I think n minus 1 is fine. Okay. Size, what is size? And I don't know, just a little bit more. Let's see if it runs. Okay. I mean, it doesn't do anything, but at least it doesn't crash, which is good. Okay. And now for queries, the index value. We have to do some stuff here first. This is only if prime sub x, then we add this. Okay. Okay. And then maybe get max. Why do I have updated? Oh no, query. I mean, query is fine, but we just want query. Man, I always forget. Okay. Node. Oh, and then also because I want the whole tree, so this is the max, right? Okay, that's the max cut, and then there's just a number of primes, so current is equal to f, or length of f. Maybe that's fine. Length of f of keys, just to be more precise because I always forget. Okay, so then now here we update. Okay, so what is the current int value? Or p value is equal to this, and then it is f of p value dot remove index. Yep, right, and then I mean we should do that, but if nums, if f of p value of 0 is equal to index, that means that we have to change the first. Actually, we could just update it twice. Okay, fine. So we can just do st update. Okay, so we subtract out what it used to be. So first is equal to f of p value 0. Last is equal to f of p value of -1. Okay, and that's only if it's a prime, right? So if prime sub p val, then we subtract it back out. We remove this. And then if primes are p val, then we just put it back in with the previous value. Okay, and then now okay. Well, we have to also check if length of p val, well, f of p val is greater than, if it's equal to 0, then we want to actually delete it. Else update. Okay, right? And then now we update the val. So num sub index is equal to value. Okay, if prime sub val, maybe we shouldn't update yet. No, yeah, let's not update yet. We want to say if, then we have to remove the previous one. Maybe I could have had a helper on this, but I don't know, too late maybe. It's fine. So then that's wrong. We want to now add it back in. And then now we update. And f of value dot add index. And then now we do this again. And then answer that append. It's just, I guess we don't need current because we're keeping track in the length of keys. Length of f of keys plus the max cut, which is this thing. And hopefully this is right. Hopefully the idea is right. One is not in the list. Which list? Index. Definition is should, right? Oh, because if it's not prime. Oh yeah, this is only if it's prime. I guess this is only if it's prime, so then here we do this stuff only if it's prime. Okay, and then if it is prime, I mean we want to update this anyway, so that's fine. And then, but this is only if it's prime. As we remove, update it even if it's not prime. Now it's a little bit confusing, honestly, but okay, fine. Power of -1. Oh yeah, we have to check that. If if length of f of value is greater than 0, otherwise we don't have to update. This is not in the tree, and that's always updates anyway. Okay. P value -1. Oh, that's nice that they highlight this actually, but okay. Oh, that's just a typo. Copy typo. This is here too then. Okay. 3, 4, and 0. Am I confident? No. But YOLO. I mean, it may time out, but shouldn't time out. I mean, okay, it's Leetcode, so it may time out anyway. But like, I don't do anything that expensive, so it shouldn't. Can I do this with prefix sum or prefix tree or whatever? Again, we're short by I mean, I was thinking maybe we can optimize this this query, but this query is fast enough because it just returns the first element anyway, right? I don't think this actually changes anything. I mean, okay, let's run it real quick. But this is stupid. Like, I don't know, 748. What do you want me to do? What do you want me to say? This takes 4 seconds. Wow, that's actually not great, but let's see if that optimizes it a little bit. get max or something. So then now maybe it'll help in the way that we don't call the max function. But okay, so what does that do? That returns, what's it called, sub.tree of 0 or 1 maybe? So it was like 4.4 seconds or something. We'll see if this is a little bit faster. Okay, not that much faster. Can I get rid of the max functions? Maybe I should have done it anyway. We don't use queries, so it's updates. Maybe I do too many updates. I don't know. But 4.1 seconds. That's what we had. See if we save time there. A little bit. Is it enough to solve 2 more cases? Honestly, unsure. I don't know that I could do that much faster though. I mean, I think this is pretty clean. Unless there's another one that I can think of. I mean, that's just sad, right? Like, it's just Leetcode not wanting to cooperate. Both this and Q3. I have 26 minutes left. Can I come up with something? I don't know. Yeah, that didn't change enough. Come up with the Java. All right, let's see if that works. I mean, it's Leetcode. It's ChatGPT. It's unsure whether this works. Where am I? Line 7. Have to convert. What is it going on here? Oh, because it's okay. This thing. Why is it going wrong again? List integer. Where's my thing? What did I do? Okay, I guess ChatGPT is converting again, so I guess I'll just do that one. But isn't it silly that we have to do this, and it's not clear that it is good enough? What is going on? Oh. There's something really wrong here. Almost clicked on submit by accident. It's so easy to quick. Oh, that's so much faster, right? Is that right though? I don't know. YOLO submit. Maybe it gives me wrong answer because of translation, but no. So it's just all Python things. So the entire contest was Python things. Which is kind of silly. But yeah, thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this contest, this problem, the explanations, everything in between. Stay good, stay healthy, to good mental health. I'll see y'all later. Take care. Bye-bye.